this up.
So we'll have to scrounge a speaker for the meeting.
Ooh, he's gone already.
Yeah. My golly, we're on the air, guys. Welcome to June. And welcome back to a Monday morning get-together, 11 to noon, the SBAU Astro Hour. It's number 171 episode, well into our fourth year of telecasting. I guess that's what this is. June 3rd through the 9th. SBAU stands for Santa Barbara Astronomical Unit. Santa Barbara, California's longtime astrophysics and telescope club, based at and supported by your beautiful Santa Barbara Museum of Natural History up in Mission Canyon, with monthly meetings, usually every first Friday of the month. Though for June, it'll be the 14th, the end, going into next weekend. Our regular star parties for the club are the second Saturday, which is regular this Saturday night, coming up June 8th at dark. Find out all about us online at sbau.org. Watch us and comment on YouTube. It's the SBAU Astro Hour. I'm your host, Ron Herron. I'm going to introduce you to the guys sharing the screen with me. We have a lot of fun. Here's what we're going to be talking about on the Astro Hour. Is there or is there not a big visible planet parade out there? Well, last week, I think it's possibly overrated, folks. We'll find out. X-class solar flares are back. A month later, maybe we'll get some auroras down here. Constellation Leo's trio of galaxies and a big spiral one out there, NGC 2903, we'll talk about. There's an easy star hop out to asteroid 2 Pallas, a new moon forming on Thursday with some dark skies and colorful nebula to visit. We thought we'd lost Voyagers out at the heliopause. Well, they're back with all of 40 watts of power for the program, and photons. Boy, I love this subject. Have no existence of time. There's no time with photons. We're going to talk about light this hour. Let's meet the gang. Our beloved president, Jerry Wilson, after all these years, runs the show. Hi, Captain.
Good morning.
He's Captain Kirk of the Starship. He's married to the lovely Pat Forgy, one of my believers. Chuck McPartlet is on screen in front of the Ukraine flag. He's married to Pat, our merchandise manager, and our new treasurer. Chuck's in charge of outreach, and we'll get a report from him, I hope, this hour. Tom Whittemore,
Morning.
former Westmont College guy, science instructor, had his own lab out there. He's married to Maureen. He's online. It's a great newsletter. Unfortunately, we got to figure out what's happening with your story there, the picture.
Yeah, after putting that pretty picture up front and everything.
Is he gone? Well, we don't have to talk about that on the air. We'll learn later what's happening. And there's Tim Crawford, my old friend, telescope expert.
Howdy doody.
Yeah. He's married to Karen, and these wives are very supportive, but God knows they're all off screen. They're never going to show their face on this. We do our silly cartoons, the forwarded silly science stuff. Most of them are about science, from President Jerry to all of us during the week. I actually keep a record of them, so we're going to get a little levity into our number 171 podcast this week with a little levity and fun. And these were great. There's about half a dozen sent out. So, Jerry, call them up.
Oh, you can't see this one?
Can't see it.
Yet.
Okay, let me try again.
Uh-oh. Warp speed, engage. I believe that's what Picard would say, wouldn't it?
Engage.
Warp speed. And here we go. Uh-oh. Got them all.
Got a bunch of them.
Yeah. Okay. 7. How about this one?
We're still learning about, we don't have, that's all of them together, Jer.
Okay.
It's just showing like your main page, not your individual.
Okay, we'll try it again. I guess I got to stop share, otherwise I'll confuse it.
I got 8. One of them wasn't a cartoon.
There we go.
Here we go. This is my favorite because 2 of our club members own Teslas. You know, the Tesla cars from Elon can now diagnose themselves. Pre-order parts if needed from the touch screen on the dash. Imagine just checking your bank account, finding out your car just ordered itself new tires, a paint job, and is paying child support to a Chevy Volt. And is sending money to Nigeria. Well, you guys will learn. It's amazing. Back in the old catapult days of warfare, the ancients would lay siege to the castle, and first, of course, they would send in the diplomats. Get ready, guys.
Pretty good. They've all got big wide eyes.
Yeah, that's the Blinkens of the world getting ready to be tossed. All right. And this
One
is
of my favorite authors.
yeah, feel good. That's Terry Pratchett. Sir Terry was I guess he just passed away. He was knighted by the Queen and he wrote fantasy stuff like J.K. Rowling said science is not about building a body of known facts. It is a method for asking awkward questions and subjecting them to a reality check, thus avoiding the human tendency to believe just whatever makes us feel good.
Mm.
Boy, ain't that true?
Yeah.
It's a certain campaign I'd love to send that to, but all right, now here comes the car shield guy on the warranty. I'm here, says the UFO, or these days UAP. I'm here about your car's extended warranty. My God, run for your lives! Not knowing that Tesla is going to be repossessed. And the new NASA director, his name is Bill Nelson. I guess this is true. He was spotted swearing in his oath on the Carl Sagan book instead of Bible. My God. And do you, sir, promise to get some respect for the little blue dot? So help you, Carl. That's great. Is that true? All right, here's some future.
I don't know if that's true or not.
I don't
but
know
it makes
either.
me
It's got to
joke.
be
I
AI.
know it is. I know it is a policy that you can be sworn in on any book you want. It doesn't have to
Really?
be the Bible.
Well, here's the original processor, according to this grown-up father of a small, soon-to-be AI robot. It's a human brain, the original process. We're long gone, of course, in that picture. A little shot of the future, what's going to happen to us.
Hmm.
And here are the Navy guys gathered on the ship, and the captain lines up our servicemen and says, all right, the command needs a volunteer for special duty. One hapless plebe speaks up. Well, what's in it for us, Captain? Okay, Captain says, just like that, we have our volunteer. Never let that happen again. I love it.
I like that. Very good.
Okay. Got the light part of the show will be at the end. I've been wanting to do a topic on light forever, but no time. We'll talk about that in time. Chuck, can you give us a quick shot of immediate outreach? What's coming up?
Well, pretty quiet month. The first thing is the normal second Saturday Star Party on the 8th, starting at 8:30.
Okay.
And with setup at 7:30 to get our stuff set up in time. Then on the 11th, Telescope Tuesday, second Tuesday of the month out at the Big Box. On the 15th, Saturday is Lopez Lake, but I think I haven't heard from anybody that's going to come to that, so that's probably just going to be me giving a slideshow. Then the 21st, the third Friday for full moon, we'll have Westmont. And then we're starting up our we normally go to Refugio State Beach in the summer quite a bit, but Refugio State Beach is still being repaired from damage that they got from storms and stuff. So instead, we're going to be at El Capitan Canyon Resort in their day use parking lot. So that's on Saturday the 22nd and Saturday the 29th. So those are our...
If we get a day like we're having today, it'll be canceled. You'll let everybody know.
Yeah. Well, yeah, I sometimes I have enough time to let everybody know, but usually I just tell people, look up. If you don't see any stars, we can't either. So,
but Chuck, will we have an issue this Saturday, or are we going to be okay for the Star Party?
We should be fine for the Star Party. The weather's not looking all that great, but as far as other arrangements, we should be all right.
Okay.
Isla will be there.
Who will?
Isla. She's the UCSB student that was helping us out at Astronomy Day.
Oh, okay. So she'll be in the dome, maybe, or
yeah.
Okay.
Well, for those that believe in global warming, I think has this been this bad in the past with cloudy days in a row?
Yes, we've had years like this. This is our well, we've got those 4 words for May, June, July, and August.
Yeah.
There's even an April one, but I forget what it is.
April.
We ought to just cover them all and just call it doom gloom.
Yeah.
And Bruce Murdoch is not with us, but there it is. That was the subject of last week's Astro Hour. Changed here, folks. My daughter sent me this picture, and I said, that was on our screen. And she said, "What? How's it look?" And I said, "I don't think we're going to be able to see much of it, daughter."
And that's not just because of the weather. I mean, really, all you would see is Saturn and Mars if you went out.
Yeah.
Oh, I thought it was Saturn and Mercury. They're too close to the sun?
Yeah, Jupiter and Mercury are just way too close, especially given our eastern horizons.
Hmm.
And Neptune and Uranus are nowhere near naked eye visibility.
Yeah.
Right, right. And I saw the moon come up this morning at 4:30.
Mhm.
It's a little fatter than what you see here.
Yeah, this is supposed to be tomorrow morning, June
Yes.
4.
Mhm.
So
Yeah.
the
Okay.
And the reason they're lined up at an angle in the sky is the seasonal tilt of our planet, you suppose?
Yes.
That's the reason. Otherwise, if we were right on solid, right on the equator all the time, and we'd see them flat across the sky.
that's why they're at the angle, but they're all in a line because they're on the ecliptic.
That's right.
And
Yeah.
they're always on this line.
That's
Yeah.
right.
This is not a lineup in real space.
Right. And the ecliptic right now for, morning is a real shallow angle.
Yeah.
Yeah.
Oh, okay.
But I'm imagining the last time we had them lined up, what was that, last year? The big gas planets haven't really moved much. They're still in their orbits because it takes a lot longer. It's the little guys inward rocky planets that have gone around several times. In
Mhm.
other words, the only ones that have changed positions are the little ones that we're part of.
Yeah. I mean, Jupiter moves by a constellation a year.
Mhm.
Is that right?
Yeah.
So it's
And Saturn is less than that.
all right. I haven't seen anything in the national news on it.
Oh, it's been all over the place. And I mean, in Jerry's write-up, you should see how crazy the description was.
I see.
Really?
Oh, they were saying, oh, it's visible before sunset, instead of before sunrise, and they were saying on the 29th, it's visible here in the southern hemisphere, and then on the 30th, it's visible there, as though it was changing around the world. And it was just total nonsense.
Well, can you guys see them only with sun filter on?
No,
No.
you can't see a planet with a sun filter on.
Right.
The only
It's
thing
only
you can
passing.
see is the sun.
Yeah.
Okay, the sun's nearby. I just thought if you blocked out the sunlight, maybe these would come alive.
It does
Yeah, but
block
if you have
out
a
the
sun
sunlight, but
filter,
it
you're
blocks
blocking out all the
light.
light. Actually, there was a guy that got an image of Venus, which is just on the opposite side of the sun right now. It's on the far side of the sun, but it's, of course, given its angle, it's appearing above or below the sun. And he got it when it was only like 38 arc seconds away from the sun.
Wow. Wow.
Yeah, so he was really risking at least his equipment, if not his eyesight.
Yeah.
Okay, so we're through with that subject, I guess. It's never happen again. Back to the sunshine.
So 3 weeks ago, we had an active sunspot group that moved across the face of the sun, and when it was pointed nearly directly to us, it dumped off or exploded an X-level solar flare that caused a coronal mass ejection to come by the Earth, and it tripped the surge protectors on both my computers.
Mhm.
So now that sunspot has worked its way around the back of the sun, and here it is coming back again. So maybe we'll be in for some more flare activities and auroras.
Yep.
When it
It
went
seems-
around the sun, it got a new name. It was renumbered. Like it was a new sunspot flare, but it's the same old, same old.
Barry, I do have a question about when it tripped your surge protectors. Is this something that kind of, I don't know how to ask this, like it would do it in Goleta but not in Santa Barbara? Is it that kind of
It could be very local.
okay?
You're just picking up a surge in the power lines, and it's coming over where you plug your things into your house.
And part of it has to do with your grounding, and currents that are in the earth that are happening because of this.
Mhm.
Okay.
I'm not totally aware of the sunspot cycle. I know it's 22 years, so it peaks. That means we get a lot of them, and then 11 years later, halfway
peaks again.
through the cycle, they almost go away. Where are we on that?
No, run. It looks like an 11-year cycle to us because the poles flip. So it's every 11 years you get the peak.
Oh,
And we're nearing a peak now.
So the whole cycle is 11 years, not 22.
No, the whole cycle is 22 years, but every 11 years you get a peak, but they're with opposite poles of the magnetic fields on the sun.
North
Yeah.
and
You
south.
get a northern
switches.
peak and then a southern peak, and then a northern peak and a southern peak.
And
I was
are
going
we-
to mention, Ron, we had a lunch guest over last Monday, so a week ago. And so I brought the 8-inch telescope out with a safe filter on it, a Botter filter, and we saw this group. So, it's come around.
Are we at the peak right now, or are we at the lowest part right now?
No, we're in a peak. We're
Yeah.
heading to the peak. We're actually, it's questionable whether we've reached the peak yet.
Yeah, so huge group, Ron. I think
And
Chuck
these-
told me it was about 20 Earth sizes, something like that.
It's like 16, yeah.
16,
at
yeah.
the last pass. It's a little less powerful now.
Okay.
The size of the spot you're talking about, the sunspot.
The size
Yeah.
of the collection of
Of
Yeah,
the
it's actually
grouping.
a complex of spots.
yeah.
Yeah.
And then somehow during all this process, the sun switches polarity.
Yeah,
Wow.
during this display, but it goes through 11 years, and then it switches polarity and it goes through another 11 years.
Right.
And so there's a peak in the middle of the first 11-year period, and there's another peak in the middle of the second 11-year period.
Right.
And that those two peaks have different polarities.
Yeah.
Different polarities on which the leading part of the sunspot versus the trailing part of the sunspot.
Yeah. And Ron, this group, if it persists, and it probably won't, it takes about a month or so to go around and reappear in the same spot.
But now
So that's just the rotation of the sun. Okay.
the sun has North Pole and South Pole like we do here on Earth, and they switch and the South goes to the North.
No, the sun is more complex than that.
Yeah.
Yeah, but kind of the overall flavor of the polarity is like you're saying, Ron. But there's multiple north and south poles in these sunspots.
Right. Right.
And none of that polarity involves plus or minus or positive and negative. It's a totally different ball game in the electromagnetic world, right?
No, if you look at the right-hand picture in this thing, you can see that in the hydrogen alpha light, you can see that the arcs or the flares are arcs. They go up off the surface and then they go down back to the surface. All magnetic field lines are loops. They don't go from something to something else. They're all loops. And in the middle of that loop is an effective vector sum of a current, a flow of electrons. And that is what produces that magnetic field. And you can see the sun is a plasma. It's a flowing ball of broken apart atoms, protons and electrons, all not bound to each other. So it's a constant crazy melange of electricity this way and that way. And every now and then it builds up so that it creates these big loops, but mostly they average out.
Really? You know what must drive astronomers crazy, including us, I guess, is that this happens probably on all stars, really a lot on the red dwarfs, I hear.
They have stronger magnetic activity.
And that's why there may not be life on the planets around red dwarfs like Proxima.
Because they barf a lot more, yeah.
That's interesting.
They're
But we'll never see it on other stars. Telescopes can't see that much, can they?
Oh,
I wouldn't sell future telescopes short like that.
yeah.
Really?
You can already see sunspots on some of these other stars,
Yeah.
and you can detect the magnetic flares, the flares that result from the magnetic activity.
Can you imagine what the stellar flares are like on Betelgeuse?
Well, see, it might not be nearly as active.
Oh,
Although it does have large sunspots. It has a lot of convection, though. Convection
Yeah.
cells driving that.
and
It's
yet
a boiling mass.
Could I ask a question on this subject here?
Go ahead.
I've heard that in the 11-year cycle that the sunspots they kind of travel. If you take the Earth as an example, you have the equator and then Tropic of Cancer, Tropic of Capricorn, and these sunspots they travel in, like say the Tropic of Cancer, and then 11 years later they're near the equator, or vice versa. That's what my question is going to be: is where these maximums occur? Do they occur at these tropics or on the equator?
They occur during that process of it moving on down. So probably somewhere in the middle would be the peak. Look up butterfly diagram. You'll see a cool picture of how they move with the cycle.
What's that again?
Butterfly, sunspot butterfly diagram.
Okay, thank you.
Well, like the Earth and like all the orbs in the solar system, the big balls, some of it's moving in the middle, and it's pretty much still, but turning in the poles, isn't it? On the top and the bottom of the sun. Do they ever get sunspots there?
They start at higher latitudes, I think, and progress toward the equator as the cycle goes on.
Yeah, I don't know if they've ever had a sunspot actually at one of the poles, but
right.
Be hard to spot.
There must be different mechanics going on, or different science, because
so it's all plasma physics. The field is called magnetohydrodynamics.
Right.
And the sun is a fluid ball, basically, whereas the Earth is not.
So, Ron, I just want to point out one thing is we didn't talk about. Can you see that kind of a darkening edge of the sun there?
On the left picture?
Yeah.
Yeah, that's a sunspot.
That's called limb darkening. Not the sunspots, just the, like that rugged edge there.
Yeah. See,
and that's because
there.
Yeah, photons are coming through thicker part of the sun, if you like, towards the telescope. And so you see this darkening.
So they've got a horizon as well.
Well, it's just, you're looking at this at an angle, Tim.
Yeah.
Okay. And so those photons are going through, the same atmosphere, but they have a longer journey, if you like.
Yeah.
Okay. Yeah.
But not all of those sunspots barf out big solar flares. Some of them just sit there benign and black. And don't do anything.
There's signs of heightened activity, but not all of them have a complex structure like this where you can get a reconnection event that causes a flare. A flare is a short-term bright explosion, and then these loops are prominences.
But the fact that they're black means that they're somewhat cooler than the plasma around them.
Yes,
but still hot.
Of course, I wouldn't want to go there.
So, Ron, the darkened sections, they're about 4,500 kelvins, and then the surface of the sun is more like 5,800 kelvins. Okay.
What's interesting about what you just said earlier, Chuck, the red dwarfs, and there's a bunch of them. There's far more red dwarfs than any other kind of stars. Really have more activity like that, and yet they outlast stars like our sun, don't they? They last longer, even with all this activity going on.
Yeah, it's just that the energy production is a much slower rate in them, but they're smaller, and you get more activity on the surface, kind of.
Well, I used to think maybe we could, if we ever visited a red dwarf star, we could come in close with our spaceship, but it would still get eaten alive and burned up and vaporized, wouldn't it? It's still hot on those suckers.
Yeah.
Yeah.
Okay.
Maybe get you a one-way ticket, Ron.
Yeah.
You wouldn't need food for the return trip.
Fascinating stuff, Mr. Prez. Let's go to the sky. Here we go.
Okay. So this is the finder chart for NGC 2903. It's basically tomorrow night at 9 o'clock, but you won't notice any difference between 9 o'clock tonight and tomorrow night. So this is where the galaxy is located. This is the constellation of Leo. This is the way I view it. It goes up here, then it goes around there in a sickle.
Right. A sickle.
And then there, under the chin of the lion, is the object we're looking for. This is a minor planet down here. This is the way the planetarium shows, software shows it up. And this is another minor planet. Let's see. This is an ultraviolet view of NGC 2309. Taken with the Galex satellite. Now, the reason they're looking at the ultraviolet is that ultraviolet is like bluer than blue, and it scatters more. So this satellite is looking for the dust. It's looking for what the scattering source is in the galaxy.
Two-armed galaxies are rare, aren't they?
I don't know. There's so damn many of these things. I'm not so sure that anything is rare.
Hmm. But it's not heading away from us that fast, so we get ultraviolet or
Oh
thought it
no,
was
you always get ultraviolet. The ultraviolet used to be X-ray, but now it's ultraviolet. It's
Huh.
just shifted a little to the red.
Okay.
It's
And this
very
thing's not
energetic.
far enough away to have a significant redshift.
Right, right. Mhm.
Yeah, this one is not far enough away. It's 30 million light years away. It's not in the billions. So it's not significantly redshifted.
Yeah.
It is part, like the Milky Way, it's part of the Virgo supercluster.
Oh,
This
And
was
Ron, in
discovered
an 8-inch
by
telescope,
William.
you don't get this detail.
Yeah.
Yeah,
Can we tell by looking at this, is it a barred?
I think, let's see, is it a
It's
barred?
considered barred, I think.
Yeah, it's a barred spiral.
Mhm.
And there's got to be other little dinky arms in between those two big suckers. They must, like spurs, like the one we're in.
Yeah, like spurs. See, there's a big arm there, and then here's another. Well, that's the start of this big arm. Maybe. I don't know. It's a lot of chaotic motion in there too.
Mhm.
Sometimes I have trouble spotting an arm, but there's a
We can-
sub-arm.
We can see this clear now because of the new moon. With a full, we wouldn't be able to see it this well.
Yes, this is right at the peak of what I consider to be the prime time to take astrophotos from your backyard
Mhm.
because there's no moon scattering. However, the clouds have run interference for us. So, although last night I got up several times in the middle of the night and it was very clear and nice starry skies.
And Ron, ultraviolet light wouldn't be affected as much by moonlight at all. If you've got an ultraviolet telescope like this Galax, you don't care about the moon.
Now the
There's such a thing. Really, there are such things as ultraviolets. That's all they watch. That's all they look at.
Yeah.
Mhm.
I'll be damned.
So the breakdown of this, because of the study in ultraviolet, is that 72% of the mass, the stellar mass, all the stars, is located in the outer disk of the galaxy. 20% is found in the bar. The bulge adds 5% to the star mass of the galaxy. So that's not referring to dust, it's referring to stars.
And since this has an NGC name, I assume old man Messier missed this one, right?
Well, yes, and it does. The major indicator of that is it does not have an M number.
Yeah.
Well,
So it
yeah,
was
right.
discovered by William Herschel
Mhm.
in 1784. It was that's my phone. Let me turn it off. It was then it was resolved into a spiral for the first time by the third Earl of Ross.
oh,
And you're going to go visit.
Yes. Yeah, next month. So the new general catalog started by Herschel gave it the number 2903. I have in my talking points 05, but a little typo there. Oh, that's right. NGC 2903 and 2905. 2905 refers to because these were looked at by the Lord Ross telescope was a big one, 72 inches, but it was all visual observing. And so they saw the core of the galaxy and they saw this bright arc up here and they thought those were two separate galaxies. So this is 2905 and this is 2903.
Oh. Something I learned, I think, about Hubble when he zeroed in on Andromeda was the part of the rotating galaxy that's coming toward us sends more ultraviolet, and the part going away is more infrared. Is that true?
No, it's so close.
Yeah.
Oh, it is?
But that's how you determine rotation of things is by the Doppler shift.
There's some slight shift, but it's not like it's a huge amount, Ron.
Yeah. You're not going to see any color change in your eye if you look at it visually.
Well, I think just looking at that, which way that's turning, it's going counterclockwise because the trailing arms.
You can't tell for sure.
I think it's going clockwise. The arms don't necessarily trail.
Really?
I just came across an animation of the rotation of a galaxy based on data, and the arms were leading in that picture. But some galaxies they lead and some galaxies they follow.
Wow. That doesn't seem like it would fit with physics to me.
Now we have to give up a lot of our easy instincts about how things are in physics.
Yeah, it's not like these arms are solid objects that are kind of uniformly sticking with each other. These are like traffic jams where there are stars moving in and out of them as the thing rotates. So it can be counterintuitive.
Yeah, I've never understood this, but I accept your explanation here.
Well,
I
now
mean,
the big monster cotton balls that are called ellipticals, they don't turn at all.
No, they're like a, what is that, a globular cluster. It's like a beehive of things, but they do have a preferred rotation to them.
Oh,
Everything's going its own way. Okay.
They may have, to my mind, the evolution of galaxies, how they turn from one type into another, if they do, is not really clear yet. Unfortunately, you can't see them transition, but it could be that the spherical galaxies, the irregulars, are about to become spirals, because if they get enough people going the right way, enough stars, then they'll start having traffic jams.
Yeah. And a lot of it is driven by collisions, more in the early universe. So that's kind of a chaotic process. And so it's hard to say, oh yeah, this is younger or older structure.
But we know they're all probably built just like our Milky Way. They've got star clusters and nebula and gas clouds. They're just
the ellipticals have less in terms of gas clouds because they tend to be older stars and they've either used up or had their star-making material stripped out of them by interactions with other galaxies.
And some of them are millions of light years across, where our little galaxy is only what, 125 million or 1,000 light years?
100,000 is
give or take
100 to 200,000, depending on who you listen to.
Recently, some definitions of our galaxy's diameter place it at 1 million. It depends how you define the fuzzy edge.
Yeah.
It's got its
It's
own
a gradual
heliopause.
transition, so you have to kind of pick a spot, like picking where the end of our atmosphere is.
Yeah.
I have a book that on galaxies, and it's supposed to be a really fascinating subject, and that I would bet that the volume I have is already well outdated from all the information coming in on the galaxies. But it's supposed to be
a lot of the stuff I learned in the 50s is not only outdated, it's just wrong.
Yeah.
Yeah, it's as soon as they publish, they're out of date, I think, that at the rate we're gathering information.
Yeah. Wow.
Well, space between the planets is different from interstellar space, and it's probably even more different outside of a galaxy, isn't it? If we could get out there, there's even less atoms, right?
Yeah.
Wow. Okay.
Well, we're back to
Borealis.
Astronomy magazine.
Right.
Hey, this is an easy star hop to find two Pallas, the second asteroid discovered.
Huh.
And let's see if I have the next chart.
Is it really going on a curve, not straight?
From our point of view, yes.
Okay. It's in the belt, right?
Yes.
It's not rogue and traveling like a comet throughout.
Right.
So you line up with, I thought I put a chart in there with epsilon. You put, but epsilon is right here. And you line this up. This is basically the right ascension axis. And here we are in June, between June 1 and June 5. We're right about in here. And so you just set the scope on epsilon corona borealis, and then you just lock it down and you wait, and Pallas will drift into your field of view.
And it looks like it's going to go quite close to T Corona Borealis, the potential nova that we're waiting for, because that's near epsilon, or between delta and epsilon, and kind of near where the 25 bit is on the path of Pallas.
Uh-huh.
So that would be cool.
Somebody asked me what happened to Serpens, and I said it went kaput.
Yeah.
Heading right for it, though, isn't it? So, do you ever occult with that one, Chuck?
Pallas?
Yeah.
Yeah, there are occultations by Pallas, but you're not learning much because it's got a pretty well-established orbit and size and everything.
Was that why learning? What would you learn? I mean, it blinks out the star. That's about all you learn, isn't it?
Yeah, but other asteroids, we don't know the shape and size very well. And if you have
Oh.
multiple people and it blinks out, you actually do cross sections of the shape of the asteroid.
And a lot of these asteroids are multiple objects, which you can sometimes see from an occultation.
Yeah.
But Pallas isn't a dwarf.
Well, it may be considered that in the future, but it's not right now.
Well, I think there's a grouping of objects below dwarf planet that is minor planet.
Which, yeah, but minor planet is like asteroids and comets and other
Right.
things, minor bodies. Yeah.
Actually, there's only one dwarf among the asteroid belt, isn't it? It's Ceres.
Yeah.
At the moment, yes.
Just one that's that size, and it's what, only 300 miles across or something?
600.
Yeah.
600. That's getting up there. It's bigger than Mercury, isn't it?
No.
No,
It's not bigger than Mercury. I thought Mercury was real small.
Mercury is real small, but not that small.
Okay.
Mercury's like 3,000.
Is Mercury smaller than our moon?
No.
It's not. Okay.
It's like 1.5 moons
I got you. Looks
in
a lot like
diameter.
it. Okay. To the night sky.
Okay, this is in
One
the
of Tim's favorites.
Yeah,
Oh yeah.
with this is in my view, it's one of the more difficult objects to find because it's so small.
Hmm.
You need a scope to see it, and it looks like a star if you're at low magnification, because you want to be at low magnification to have a big field of view. And so it looks like a star. If you focus in on it with a higher magnification, you can see that it's a small bluish disk called the Blue Snowball. It's a planetary nebula. It's located near the Andromeda Galaxy. This is rising in the east in the mornings. Whoops. Do I have yeah, this is 3 a.m. On the 5th, Wednesday morning at 3 a.m. So it's got a good height to it.
It's kind of an autumn object in the evening.
Mhm.
But this is one
Oh,
of
okay. Autumn.
is one of Chuck's
Tim
Hosta
has-
nebulas.
Tim has a star hop to it.
Okay.
Go ahead, Tim.
Yeah, this object, when you look at where Andromeda is there, but the first thing you do is find that great square of Pegasus, which here is just on the lower right. And then you can see where Shiat and Alpheratz are in the upper left and lower left corner of the square. And that side, you want to pay attention to that side of the square and then kind of look out 90 degrees and it'll take you near. But naked eye, Iota, Andromeda, and I think Omicron, those are the two stars that draw a line there. It's not right on that line, but it's about a third of the way from Iota Andromeda to Omicron. So
And
those
it's
two
somewhat
stars,
similar to finding the Ring Nebula using the two stars in
that's really a good comparison. Really good comparison.
Looks like
So-
there's too many. Is this
No,
five?
the one
And
at the
this
end
is
of the
this is
line,
Kappa and this is Iota
right
here.
there. That's it. That's
That's Iota.
and then Omicron is on the other side of that line.
Up
Yeah,
There it is.
there, the O.
And so you go a third from Iota, just about a third distance, and it's just off of that line. But
Yeah.
you notice that it's just not like other stars. It's bluish and it's a little
Yeah.
fat. But that's how I find it. There's not a real great way. You can't say, oh, it's an equilateral triangle, which it looks like. But
Well,
the
from
best-
here it is.
yeah. But the best way that that's kind of like an equilateral triangle. That's one other way of looking at it. But the naked eye stars are that Iota and Omicron Andromeda, and it's on that line.
Okay.
But the Blue Snowball is blue colored, right?
Yeah.
Why?
Well,
Oxygen.
yeah. That's like a lot of the planetary nebula. They barf off all these layers of gases, and in this case, that blue spectrum comes through.
So that
You
was
say it's oxygen, Chuck?
Yeah.
Yeah, and so
so it's emanating ultraviolet more than anything else,
No.
or
Blue more than anything else.
blue.
Okay, blue.
Yeah.
Blue is
It's
right
just
below
because of the
ultraviolet.
eyes. It's because of the eyes response spectrum.
Yeah, that's exactly
So
right.
you don't have to learn Greek to learn astronomy, but you should familiarize yourself with the Greek alphabet. Only 26 symbols, and they're largely intuitive because our
24.
alphabet is loosely
24,
related.
Jerry.
24.
Yeah.
Thank you.
You got to forget a couple.
Wonder how many Greek words are available left, if any, that aren't named on something.
There's nothing.
There, it's all gone, huh?
In
Greek,
physics, they
Roman.
use all the English alphabet. They use all the Greek alphabet. They've started on the Hebrew alphabet.
And a lot of Arab.
In mathematics, there's a lot of Hebrew. The Aleph, which is
Yeah.
their A,
Yeah,
stands
Aleph.
for different
Yeah,
types
Aleph,
of
no.
infinity.
Mhm.
Maybe they'll have to start naming them like zoology names new species. They put somebody's name in there and add Ithias or Isium or something. Or new elements, Californium, Fermium, you know.
Well, you want to use symbols that are short, so you can the
Neil deGrasse Tyson's
computer
telephone
program
numbers.
can have a variable that's a name, but not when you're doing it by hand.
Yeah.
This star hopping that I do, a lot of times you'll see patterns, like when Chuck was saying, this is reminiscent of looking for the ring nebula. That's really true. There's another one here. If you take the square and you make that Hercules, on that side of the Hercules square, out about where the blue snowball is, will be M92. We'll see that later in Jerry's talk.
Mhm.
Okay.
There's a lot of
Moving
patterns.
along.
They just keep coming up.
Here's our blue snowball.
This is a Hubble image of the blue snowball with its white dwarf at the center. These are different layers that at different times it has sloughed off.
It looks like a precious gem.
Yeah.
It does.
It's an opal.
It's whatever the shape is, it's sort of focused right at us. We're looking down the tunnel of it. It
Oh,
doesn't,
okay.
it's not necessarily a sphere or an ellipsoid.
So that's a
Most of these
star-based. Okay, sorry.
Most of these are sort of hourglass shaped, so we might be
Yeah.
looking down the base of the hourglass.
Is that Voyager?
Yep.
This is
We're on to the
Voyager.
new subject. Voyager is still alive at 40 watts, or about like a 40-watt bulb, still
Yep.
sending from that far out in
And
space.
it's not from solar panels.
No.
They have a nuclear reactor on board.
Well, sooner or later, the extraterrestrials are going to find Carl's little, golden discs, and we're going to be long gone. It won't matter.
And then we'll send out the Apollo G satellite. So
Okay,
these
they
two
reestablished.
these two probes, Voyager 1 up here and Voyager 2, they left the inner solar system and made a grand tour of the planets here, Uranus and Neptune, and then they just headed on out. So they are now on this
The
map.
heliopause.
Yes, they are. This is the heliosphere, which is where the solar wind brushes up, or rather runs into the interstellar magnetic fields and dust and particles. And this is a bow shock that we create. It's not this bright or dramatic. This is a artist's conception. It's not a photograph, obviously. This is the termination shock. This is the heliopause sheath, heliosheath. And this is the heliopause out here. They're both past the heliopause. They are in interstellar space.
But Jerry, can I ask this? Because of the way this looks, everything's being shot to the left. That means the
Yep.
sun is out of sight to the right?
No, the sun is right here in the middle.
Oh, I'm sorry. I thought that was our planet we're looking. I'm sorry.
Well, it
Okay.
is. Our planet is right in there somewhere.
Okay, I got
This
it.
is the sun, and the sun's solar wind is going out. We're trying to go out in a spherically symmetric pattern this way, but it's running into the motion of our sun through the galaxy is taking us all with it, and it's running into material out here that's not necessarily moving the same way as the sun. So we're having to plow through it. It's very tenuous material. It's not like we're hitting a tidal wave hitting us. But we are,
They are going away from the sun.
they are going away from the sun right there. And
Okay.
what they're principally doing is counting the particles, what type and how many. And that's very useful for it gives us the density of things. When they pass these two termination shock and the heliopause, there were definite changes in their counting and what the species they were counting and how many of them. Now this thing bounces. This is not a rigid structure. It moves back and forth depending on the density of the material that it's passing through. So this is kind of a compromise, a wind going this way and a wind going that way. And
They're
so,
still sending information, Voyagers?
yes.
Huh.
What does it take? 22 hours or something to get from there to here?
Yeah, 22 and a half, something.
Wow.
Yeah.
Wow.
But it hasn't passed. They haven't passed through the Oort cloud, though, have they?
No,
So that's right about where would the Oort cloud be in this picture?
it's filling the whole thing.
Oh,
It's like 2 light years in radius, depending on who you talk to.
These
oh,
are
is it really
this
that
is
big?
this
Wow.
is the structure created by our solar wind in the galaxy. The Oort cloud is a structure created by the sun's gravitational dominance. So if something came real close, it could strip a lot of our Oort cloud away, or it could add to it, depending on the dynamics.
Wow. Wow.
Boy, I tell you, those of us who live on YouTube, every week there's a new scary video saying, "Guess what Voyager just ran into?"
Yeah, it creates headlines.
Where do they come up with this stuff?
So there are 4 instruments on board. They had to do a little juggling because one of them failed. And so they had to take their programming and break the programming up into 4 parts on one of the Voyagers and distribute it to other parts of the computer that weren't damaged, and then get those all coordinating. And then they brought it back on. They brought 2 of the 4 instruments back online. And they're working on getting the other 2 back on. But the main thing, the counting and stuff and the species are there. So
Oh,
they're back getting data. It's amazing.
yeah. Maybe
Hmm.
that movie will come true.
Oh, yeah, don't count on that. There's a little article that Sky and Telescope had about the circumpolar constellations. And your Ursa Major is one of them, and that's what this is a picture of. These are the names of the stars in Ursa Major, and it's the dates when the light from that star left that star to be in this photograph. So, but the thing that happens that is notable is that it appears to change over the night. It's going over the top around the pole, and so it changes its aspect from dipper up to dipper down, or handle down to handle up as it goes by. So you can see quite a change in the night.
Looks
Now,
like
this
a
one,
looks like a professor's Sean Kelly weekend assignment to his astronomy class up at City College. Get to know these names and when
yeah.
they discovered.
Not when
Oh,
they're
we did.
discovered, Ron. This
No.
is when the light left them.
Yeah,
Oh, really?
yeah.
Mhm.
So
Okay, they're all
they are similar distances away. And there is an association of stars in Ursa Major that is believed to be the remnant of our star cluster that we came from, because they're similar spectral types to our sun, and they're moving with motion similar to our sun through the galaxy.
And it also includes a couple of bright stars in the winter sky, like I think Procyon and Sirius.
There is. Mhm.
Well, there must be computer programs that can show what the night sky is going to look like a few thousand years
Oh yes,
away.
virtually
Oh, sure.
any planetarium software you buy will show you way in the past and way in the future if you dial that in.
Ron, I did a little study on this in the last couple of weeks, and I had an image from, I don't know what it might have been Astronomy magazine, and it showed the directions that the stars are going in. And they're what they claim is that all these stars are coming towards us. So I took my planetarium software and I threw it out like 50,000 years, and there was very little change in the positions. I think the star Dubhe is one of them that, if any, it's going the opposite directions of the other. It might be Alkaid and Dubhe.
Yes.
And
Well,
those are
Dubhe
going,
is obviously the farthest one away from us.
yeah, and it's
Like
going.
then Alkaid. Then the rest of these are all in World War II.
Yeah, yeah.
And all the World War II ones there are the ones that share the same motion.
Yeah.
Yes, yeah. But because they're coming towards us, there's very little change that you would notice. And I only went out 50,000 years. I think what I'll do is throw them out there like about 1 million and see what happens.
And
I love
Dubhe,
them.
if you do that motion over like 100,000 years, Dubhe moves way to the left in this image. So it looks like you're bending that bit of the dipper out.
Yeah, it's not. I went out 50,000 and it hardly moved at all. So that's the one that'll move is Dubhe.
Yeah, don't
Well,
want to.
since it doesn't
Great.
change, did the ancients call it a
Yeah.
dipper?
Sure.
Yeah. Or
Did it really?
Plow.
But
Some
Ron,
stars,
when you're looking at recorded history, you're not looking back that far at all.
yeah,
And Jerry's birth star is McGrath.
yes, it is.
Sort of reveal that,
And
Jerry.
Merak.
There was a Sanskrit word that I saw in, I think it was Alcott's book, and I can't remember the word, but it was maybe misinterpreted, and one of the meanings was bear, and that's might have been where this idea of the bear, the great bear, came from. But the Sanskrit word, it had a different meaning, and I think it meant bright stars. But so I'll have to go and revisit that.
Yeah, it's a good
Well, I
book.
remember that there's an old Arabic or Middle Eastern document that refers to a nice bright white star we see today, but it calls it ruddy, which means kind of reddish. Which star that is.
Hmm.
Yeah.
And McGrath has seemed to me, at least, to have gotten a lot dimmer over the years.
Huh.
Good memory.
Okay, so there's been large spoons or ladles throughout history. Back what, 5,000 years before that?
Well,
cavemen.
wagons, wagons or
Yeah.
plows.
Yeah.
Yeah,
And
the French call this le casserole.
Oh, really? And
Yeah.
the bear thing came along later, I guess, right?
No, the bear thing, it just depends what culture you're talking to.
Right, right.
Well, Mr. President, is this going to lead into photons and no time? Or we're going to
you want
night
to go
sky?
to this is June. This is early morning. Looking west. This is the after the moon, full moon.
This is evening sky.
Yeah, yeah.
Right.
Mhm.
And this is the waxing moon after new moon in the evening sky, June 7, 8, and 9.
Mhm.
And Castor and Pollux appearing to walk over the neighborhood. And Procyon, second brightest star in the sky, and mentioned earlier.
That's
Now,
not
this is a
second
very-
brightest, but
This
But
is
it
a very interesting picture. This is Io, of course, and this was taken from an Earth-based telescope. And
Tom,
that's
this is where I was telling you about the large binocular telescope getting these images.
yes.
You can see all those scores,
And this
swords
is-
and scales on it.
This
Up
is
on
the telescope
Mount
itself.
Yeah.
It's the large binocular telescope. These have what, 9.5 meter across
Yeah, big.
mirrors. Two of them.
Boy, I'd hate to hold those.
8.4 meter aperture mirrors, equivalent to an 11.8 meter aperture for light gathering, and 22.8 meters across laterally for resolution. Because
Wow.
they can form an interferometer between the two of them and bring out a lot of detail, and that's what generated that photo of Io. That is the sharpest photo of Io ever taken from an Earth-based photo
Yeah, and that
Really?
telescope is south of Tucson. I've climbed that mountain.
They
What
wouldn't have
mountain
been
is
able to
that?
get that picture with just one of those two scopes. It had to be binocular.
Yeah, it
Yes.
had to be, you need two of them.
Huh. Well, that's pretty much the reason they lay out radio telescopes in large arrays on the desert floor, isn't
Yes.
it? You know?
Do interferometry.
Okay. Yeah, there we are
This-
again. I've seen this picture before.
Yeah, this is the large binocular telescope on Mount Graham. And these are the two mirrors. And this dotted line is the equivalent, if it were one mirror, because the
Mhm.
light is added together and the resolution is increased by the spacing here in this direction. This is the equivalent mirror that it would be if it were one mirror.
Wow. Wow.
And they're going to do the same thing with the very large telescope in Cerro Paranal.
And with the
this
keck,
way. What's that?
with the keck in the upper right.
Oh, yes.
Mhm.
Yes, you're right. And it has an equivalent of it also, which is just slightly larger than this. And
Boy, oh boy.
this extremely large telescope, I believe that one is running into funding trouble.
Yeah,
Well,
I heard something about that not going forward. I don't know where that stands.
Yeah, they're building the 30 meter and the giant Magellan telescope is nearing completion. I think they're putting in the last mirror or something. And
It's the overwhelmingly large that really got wiped out.
Yeah. The
Oh,
owl.
okay.
The owl.
is that another word for the extremely large?
No, you can see at the
No.
very bottom here, it was really, really big.
Oh, yeah, I missed that circle. Yeah.
Wow. That would have
There
been
you are. Canceled.
Yeah.
But for a whole different reason, the two in a row, which become binocular, is different from us looking through binoculars. We don't get a depth thing. It's not a parallax at all.
No, it's not there for the reason that we have binocular vision. That's true.
Mhm.
Fascinating. Wow. And down in the lower left is the old Webb. Thought it was bigger
Yeah.
than that, but I guess that's pretty good size, isn't it?
This is
Yeah.
very big for getting it up into space.
Yeah.
Yeah. Wow.
What in
There
the
are
world is
plans
those-
to build a large telescope, a faceted telescope on the backside of the moon.
Yeah, look at the Palomar telescope over there, the Hale telescope, 200-inch. And the Webb is pretty big compared to that.
Yeah.
What did you say about the backside of the moon, Mr. Prez?
Oh, I know there are plans, speculation to build a telescope on the backside of the moon.
Well,
Not
are
in the
you
near future, but eventually.
are you aware of one of our big superpowers on Earth just landed there?
Yes.
That'll be a future topic, I'm sure.
Yes.
Yeah, hopefully they'll share their pictures.
So far, we just have a fuzzy video of the thing looking for a landing spot and then all of a sudden plopping down. But I guess it didn't tip over.
Yeah.
And
So we'll
it's
talk
robotic.
about China's effort.
And it's going to return samples, which is a big deal.
Yeah.
What's the name of it? Do you know?
No,
It's Tianji something.
yeah.
Okay, Chinese. Okay, what is this?
So we will conclude with this.
Light waves are us.
This is T. Corona Borealis, I think, right?
Yeah, this is CT Corona Borealis. This is an artist's conception of the very beginning of the nova. This is the white dwarf star here, and this is the large giant star that is having hydrogen stripped off of its surface and piled up on the white dwarf star until enough of it is there and it's hot enough that it starts an explosion. And this is the shock wave of that explosion just starting out. So this is the very initial instance of that nova explosion.
Well, is it going to increase in size over the next years?
Whoops.
No.
Or is
No.
that pretty much how it's going to look from now on?
Well, no, it's going to explode. So you'll get a bright nova for a while and then it'll dim back down.
Yeah.
Okay. We're going to be able to talk about light waves and time,
Um,
or you want to shelve that? That could be a deep subject.
yeah, I don't know that we have that in this week's talking points.
Oh,
Well,
you did.
it was in the caption for the picture of the Big Dipper. talking
Okay.
about when that light left there, but to the light photons, they experience no time coming here.
Yeah, we will have to talk about that at another time.
Mhm.
Ooh.
That's going to require about 10 minutes or 15 minutes. Okay.
Well, you've fascinated me again. Thank you, gentlemen. And I guess we're dead ahead. We got next episode number 172 will be next Monday. We are here with Cartoons and Cosmology every Monday morning, everybody. 3.5 years now, going into our 4th, all archived on YouTube, comments, and everything else. June general meeting is a week from Friday. This Saturday night is our star party. And doggone, I'm not sure who our speaker is going to be on the night of the 14th. And we got to talk about that somehow.
Can we still have John?
No,
Oh,
He's
apparently not.
okay, but he's going to be there Thursday night for our little get together downtown, I guess.
who knows the most about moons of the solar system?
I have a check written out for him already. I don't know if he could use the money, come back and they'll let him. Nevertheless, join us. Join us at the
Okay.
parties and join us online every Monday morning for the SBAU Astro Hour. Thank you for coming. Give my love to your ladies and everybody else, and we'll see you next Monday morning.